We are going to start Unit 9. Unit 9 is a huge calculator unit, meaning you will need a calculator on almost every single homework assignment, and you will need a calculator for every single quiz and test question that we have. The numbers are kind of big that we use. Sometimes you're going to be using something called radical form. So once again, the calculator I have recommended to you does radical form. I do recommend using it. It also keeps things in terms of pi, which will come in handy on certain questions in section 2, which you will see in a little bit. So 9.1 is on the area of regular polygons. The key word here is regular. The word regular means they have congruent sides and congruent angles. All sides are the same. All angles are the same. What we are doing only works for regular polygons. Now, there's some terminology that you're going to need to know. You're going to need to know what the radius of a polygon is. And you're used to a radius of a circle, but what about for something that has pointy edges? Polygons are made up of straight sides. Straight sides. And if I have a radius of something with straight sides, like a regular hexagon, then the radius is from the center to the vertex. That means to the places where the angles are created. That's a radius. I could even draw another radius if I wanted to. I can draw another radius if I wanted to. These are radii, I guess would be the plural of a radius. And they go from the center to the vertex, the vertices, the places where the angles are. The apothem, on the other hand, that's a new word for you. The word apothem is going to go from the center that is perpendicular to the side. The apothem is made straight. It's the shortest distance from the center to the side. We have to know the difference between these two things. These are not the same length. The apothem and the radius are never equal to each other. The apothem is something that we're going to use to find the area of a regular polygon. So here's an example that I have for you. It's a regular hexagon, meaning it has 6 sides. You will have to know on the worksheet today the names of the polygons. Your key terminology is dealing with the word, like look at your prefixes. Hexagon means 6 sides. You might have to know what a pentagon is. You might have to know what a decagon is. You might have to know what a nonagon is. Those are all things that have, those names mean a certain number. Hex means 6, has 6 sides. You are expected to know that. If you have questions on that, feel free to look those things up as you go. I will give you examples of other ones that I think are less common, but that you should still know. Okay. Every regular polygon is made up of isosceles triangles. So I want to show you that. Let me show you what I mean. If I look at this particular hexagon, I know that if it's regular, then I'm going to have 2 sides that are definitely going to be the same and 2 angles that will be the same as well. So it doesn't matter if it's a pentagon and have 5 sides, or if we're talking about a heptagon that has 7 sides, but you can always cut the regular shape up into isosceles triangles that have a vertex angle and 2 base angles that would be the same. And why are they made up of isosceles triangles? Because every side is the same and every angle is the same, and so we're cutting everything into equal pieces, which should hopefully make sense to you. So the first thing that we have, the first formula that you have is, how do I find the vertex angle? And it's 360 degrees divided by s, where s is the number of sides. What does that mean? That means this, and I'm going to just label it in this picture. I'll label it here in a different color. I don't have, let's label it in purple. This angle That angle there is your vertex angle. That vertex angle is the top of the isosceles triangle. These are called base angles. This is your vertex angle. Now notice the vertex angle is not made with the apothem. The apothem splits the vertex angle into two pieces. So if I'm trying to find the vertex angle, the easiest thing for me to do is to take 360 degrees or all the way around a circle and divide it by however many sides you have, because these vertex angles should end up being equal to each other. That's the first formula we're going to use. The other formulas that we're going to use, and it might be this one or it might be this one, it just depends on what you're given. They are equal to each other. This is the same thing as this. 1/2 the apothem times the perimeter, or 1/2 the apothem times the number of sides times the side length. That's what these formulas are. The perimeter is the same thing as the number of sides times the side length, just so you know. So you will be expected to memorize these two formulas. 1/2 A times P is the area of the polygon, and things that you will need to know isosceles, how to deal with isosceles triangles. That comes from 3.5. Equilateral triangles, which comes from 3.5. If you need a review on those things, make sure you go back to the 3.5 notes. If you don't remember your 30, 60, 90 degree triangles, you might need to look at 7A.2. If you need 45, 45, 90 degree triangles, review 7A.2. And there is at least one problem from SOHCAHTOA back in 7A.3A notes. I put them down there for you. And that brings us to the end of our notes, and the rest of these things are examples. As you know, you are welcome to do these in your packets with me, or you can do them in your notes. It's up to you. First one I picked out for you is number 3. Each regular polygon has a radii, that's plural, means more than one radius, and apothem as shown. Find the measure of each numbered angle. Number 1, angle 1, is a vertex angle. If I look at this vertex angle, angle 1, it's going to be the same as this angle. It's going to be the same as this angle. It's going to be the same as both of these angles. It's going to be the same as this angle. This is why I wanted to tell you that I can see these things as a bunch of isosceles triangles. If I want to figure out what angle 1 is, I'm going to use that first formula that I gave you, which is right about here, to find the vertex angle. So to find angle 1, I'm also going to call it a vertex angle. I'm going to do 360 degrees divided by what number? How many sides do we have in this pentagon? Now, I don't really like to do 360 divided by 5, so I am going to break out my calculator. You could do it by hand, but sometimes just using the calc makes things a little bit easier. And so if I divide it equally, I get that this angle is 72 degrees. That's my answer for angle 1. This is 72, this is 72, this is 72, this is 72. Now angle 2 is not 72 degrees. Angle 2 is formed by the apothem and the radius. So what I have to think about that is that by, remember how this is an isosceles triangle and this angle is the same as this angle? By angle, angle, side, angle, angle, side, I know that these two triangles right here are congruent to each other. Because they are congruent to each other, that tells me that angle 2 has to be half of the vertex angle. Whatever my vertex angle is, if I cut it directly in half, that's going to be what angle 2 is. Think of that apothem as cutting it right down the middle exactly into 2 congruent pieces. So what I'm going to do is I'm going to take 72 degrees and I'm going to cut it directly in half, and I think most of you know what the answer is for angle 2. Angle 2 is how many degrees?
36 degrees.
Good job. And angle 3. Angle 3 is formed from this right triangle. I have a 90-degree angle. I have an angle 2. So angle 2 and angle 3 are complementary. For me, the easiest way to find angle 3 is to do 90 degrees minus whatever angle 2 is. That's how I do it. It's complementary because all 3 add to 180, and that's just the shortest way to get to the answer. 90 minus 36 is, if you need a calculator, use a calculator. I believe it's 54 degrees. Do you agree with me? Okay, good. Find the measure of each numbered angle. You will have several problems like number 3 where you're finding a vertex angle first. Use that formula, which we have right there. Second angle is going to be cut by the vertex angle cut into 2 pieces, and then the angle 3 will be the complement to whatever angle 2 was. Now let's make it harder. Number 9. Find the area of each regular polygon with the given apothem and the side length. What I want you to notice about what is given, you're given a side length S and you're given an apothem A. And I gave you 2 formulas that you could use. You could use this one that has a perimeter, which you're not given, and you're given a side length and an apothem. So what aren't you given that you would need if you're using this second formula is you need to know what n is, and n is the number of sides. What you're going to have to do on number 9 is you're going to have to know how many sides a dodecagon has. Now that's a weird word, dodecagon. I'm sure your 4th and 5th grade teacher taught you what a triangle was. I'm sure they taught you what a quadrilateral was. But I don't think that they taught you what a dodecagon was. Maybe they did. If you don't know, you look it up. I looked this up. A dodecagon has, guess how many sides? If you think you have a good guess, tell the person you're sitting next to. I know, random. It's 12. Okay. If you didn't know that, guess what? I didn't either. Does it make you feel better? Maybe. I know. Here's what I know. Pentagon, 5 sides. Hexagon, 6 sides. Heptagon, 7 sides. Octagon, 8 sides. Nonagon, 9 sides. Decagon is 10 sides. 11, I don't know what it is. I actually think it's actually pronounced, or they write 11 gone as 11 gone. Most of the time after 10, they usually just do this. In most geometry textbooks, like 12 gone, 14 gone. Makes it easier. Dodecagon, but there is a fancy name for it, so there you go. Now that we have that, and I'm trying to find the area, I'm going to put my formula down here. 1/2 the apothem times the number of sides times the side length. 1/2. What's my apothem? 40.6. How many sides does a dodecagon have? Thank you. What's the side length? And this is why we need a calculator, this unit. The other thing that I do is that if it doesn't say, I'm not going to round it. I'm just going to plug it into my calculator and go from there. 1/2, I usually put in as 0.5 in my calculator, times 40.6, times 12, times 21.7, and I'm a firm believer you should put the whole thing in your calculator. That way you can double check. Does this match with this? Does it match with this? Okay, I typed it in correctly. The hardest part about using a calculator is, did your finger hit the right button? Some of you have big thumbs. Some of you girls have really nice fancy nails. They get in the way sometimes when you're using a calculator, so make sure you're punching in the right buttons. How do you check? Read your screen. Does it match with what you have on paper? Make sure you're writing down what you're plugging in, because if on a test question you get it wrong and I don't see this, you don't get any partial credit. I give you 0 partial credit unless I see what you're typing in. That's how I've been grading you from the start of the school year. Make sure you write down what you're punching in. Then I press equals. It gives it to you in a fraction form, but you're going to switch it to a decimal. And if it doesn't say what to round to, just write the whole thing. This is area. We're going to put down meters squared for our area. But I read the directions, because the directions might say round to the nearest tenth or keep it in radical form, whatever it says that we have to do. Turn off that light. Number 10. This is where it gets harder. This one's kind of nice because I just had to know what Dodecagon was and plug it into a formula. But what happens if they don't give you a formula and they give you a picture? And they just give you a side length, like number 10. Rounding our answer to the nearest tenth. Okay, so here's what we're going to do. I need to know what the apothem is. The good thing is that I have learned enough geometry in my previous units that I should be able to figure this out. This side length is 12 units. We know that there are 6 sides in this hexagon. But I don't know what the apothem is. So here's what I'm going to do. I'm going to draw an apothem. Hopefully I can draw a straight line. Let me cheat a little bit. There's my apothem. And I know that this apothem is at a right angle. And I know that the side length is 12, and since it's a regular polygon, this is 12. And down here, instead of putting 12, I'm going to draw a radius as well. Ooh, I should have drew that straight. 6. Isn't that little side right here 6? Isn't that half? Now it's a hexagon. Here's what you need to know about a hexagon. Every single radius, if I draw that hexagon, I have, this is the same as 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 this. Hexagons are made up of not just isosceles triangles, but hexagons are actually made up of equilateral triangles. And so what that means is that this angle here in an equilateral triangle is 60 degrees, this is 60 degrees, and this is 60 degrees. I'm just going to draw that right there so you can see. And this only works for hexagons right now. It would also work for equilateral triangles. Those are the only two. And so if I think about that, that means that this angle here has to be 60 degrees, and this angle here has to be half of that vertex angle, which is 30 degrees. Now this has to be 12. And so I need to figure out what this apothem is. And I'm going to put a little A next to it. I'm hoping what you see is a 30, 60, 90 degree triangle. If you do not know your 30, 60, 90 degree triangle, you may need to review previous notes. I'll kind of draw out over on the side a 30, 60, 90, just so you can remember what the shortcut is. When we learned this way back in the when, across from the 30 was S. Across from the 90 was 2S. And across from the 60 was S root 3. You will be using that quite often, this unit. So if I look at that, and I know across from the 30 is 6, and across from the 90 is 12, that fits this because that's twice as big as what this bottom piece is. And so how did we use it? S has to be the same as 6, so that must mean that our apothem, if you know what your apothem is now, tell the person you're sitting next to. I heard several of you say 6 root 3, which is great. You're going to have to figure out what the apothem is on a lot of problems by drawing out what I just drew for you using 30, 60, 90 degree triangles. So here we go. Now I can go into my formula. The area formula is 1/2 the apothem times the perimeter. 1/2 my apothem is 6 root 3 times my perimeter. Oh, only given is 12. Hi, perimeter is 12 times how many sides? 6 of them. I was asked in the problem to round to the nearest tenth. So that means I'm going to have to switch this to a decimal, and I'm going to plug everything in. 0.5 times 6 root 3, get out of the radical. 12 times 6. Now, oops, times. There we go. One thing, like I said, I want to make sure I am multiplying, and the 12 and the 6 are not underneath the radical. So let me look at this and show you. See how the radical ends right there? I'm making sure the 12 and the 6 are not underneath that radical. I don't want to square root the 12 and the 6. I only want to multiply by the root 3. And then I want to switch this to a decimal to the nearest tenth place. Here's my tenth place. I look at this number. It's not 5 or higher. I'm going to leave this the same. 374.1 inches squared. Number 18 and 19 are our last two, and then we'll be done. Number 18. If your answer is not an integer, leave it in simplest radical form. Is this the apothem? No, it is not. Is this from the center perpendicular to the side? No. Because it is not, you're going to have to do one of two things. This is actually called the radius. And so what I'm thinking is I could either figure out what this piece is, or I can figure out what this piece is. So here's what I'm going to just draw for you. Let me use a straight line that's perpendicular. That looks perpendicular to me. And I know that that one side is 20 over 3, whatever that is. This is where it is helpful for you to know it's a regular polygon. Every side is the same. This side is the same as this side is the same as this side. That means it's equilateral. That means that this angle is 60 degrees and this angle is 60 degrees. And what does that mean? What does that mean that this angle has to be? That I am pointing at right here. And then, once again, now we have another 30, 60, 90 degree triangle. If you need, you can write S across from here, 2S there, and S root 3 right there. I need to figure out, in my formula, I need to know what the side length is so I can find the perimeter, and I also need the apothem. The only way to get to it is to use this 20 over 3 and know that's on the 2S side. This 20 over 3 is equal to the 2S side. So if I want to know what S is equal to, I have to divide by 2 or times by 1 over 2 to both sides. Oh, I know what that is. I know what S is now. S has to be 10 over 3. What does that mean? This side here is 10 over 3. What else does that mean? That means your apothem is 10 over 3. You could turn it into a decimal, but right now it's easier to write it as a fraction. This other side, that is S root 3, this is S, that's S root 3. All you do is take this 10 over 3 and you write 10 over 3 times root 3. That root 3 is multiplying the numerator. So it's 10 root 3 over 3. It's rationalized. It's kind of nice. But that's not our side length. That's only this distance from here to there. So that must mean that this other side length is 10 root 3 over 2. And if you were to add 2 of them together, you can finally get your side length. From here all the way to here would be 10 root 3 over 3, Mr. Paramo, plus another 10 root 3 over 3. Guess what that is? That's 20 root 3 over 3. Now I have my side length. Now I have everything I need to find the area, but I need to leave this in simplest radical form. So let me write this out for you so you can see what I'm going to do. Area equals 1/2 the apothem times the perimeter. 1/2, my apothem is 10 over 3. My perimeter, I have a side length of 20 root 3, and I need to multiply that by how many sides? 3 of them. Because it says radical form, you're not going to touch this root 3. That root 3 is what you're going to leave alone. Your answer is going to have a root 3 in it. You multiply everything else. And so if I was doing this by hand, because I like to do some things by hand, like, so if I go 3 goes into 3, that just goes away. The 2 goes into 20 10 times. 10 times 10 is 100. Bottom denominator is 3. This is what I'm getting by hand. I'm going to check on a calculator though. 0.5 times 10 over 3 times 20 root 3 divided by 3 times 3. Whoa. 0.5 times 10 over 3 times 20 root 3 divided by 3 oh, maybe it's too long. Well, you know, let's delete that. Maybe I've reached the threshold. 20 divided by 3 times by 3. No, it's still giving me an error. Interesting. Good thing I did it by hand. I don't know why that happened, but I'm not going to spend time right now figuring it out. One other thing I could say. This says 100 over 3 root 3. If you gave me your answer as 33.3 root 3, that would also be acceptable, I guess. But this answer is okay. I'm good with that. Number 19, the last question that I have for you. A lot of notes today. I'm sorry. That's how it goes. You're given a diagonal of a radius of a regular square. A regular quadrilateral is a square, by the way. That's what I meant to say. There are several ways you can do this. You can figure out what the apothem is, just like we've been talking about. You could, but if you do that, that means that you're going to have to realize that this is a 45, 90-degree triangle, and you need to know the shortcut for that. This is the S root 2 shortcut. The 20 millimeters is on the S root 2 side. S root 2 equals 20 millimeters. If you want to know what S is, you would divide by root 2 on both sides. You would rationalize this, and it comes out to 10 root 2. If you don't know how to rationalize, you multiply by root 2 over root 2. You get 20 root 2 over 2. 2 goes into there 10 times. That's the long way to do it. I kind of just rationalize in my head sometimes. That means your apothem is 10 root 2. Your side length is not 10 root 2. Your side length would be 2 of these added together. 10 root 2 plus another 10 root 2 is 20 root 2. So to find the area, I would do 1/2 the apothem times the perimeter, 20 root 2 times 4 sides. Now this is why it's helpful to still know how to do this stuff by hand, because I can do half of 20, which is 10. I can do 10 times 10 times 4. 10 times 10 is 100, times 4 is 400. Root 2 times root 2 is the square root of 4. Guess what that is? 2. What is 2 times 400? Is 800 millimeters squared. That is one way to do this problem. I like to think of squares as, oh, you could do this in a different way. I just want to show you one other way that I like to do when I see this, because I see it as 4 triangles. Let me do this in a slightly different color. If I were to highlight from here to here and here to here, and I were to highlight from here to here and here to here, color this in. Just because I see it this way, maybe you don't, and I want you to see this through my eyes. If I were to take this green piece over here and move it over there, would it make a perfect square for the green pieces? If I were to take this green square, and I know this isn't great, but let me just put some red lines here. Here, oh, that's not red, Mr. Paramo. Let's go with a red. Oh, that didn't work, Mr. Paramo. Whoa, whoa, red. Red line. Here to here. One more red line. Please, computer. That's not red. That's not what I was going for. Oh, that's not what I wanted to do either. Trying to be fancy. If I were to take that green piece that was over here on this side, and I were to move this green piece over here, would that make a full, perfect square over there? And I'm hoping you see, yes, it would. And so if I can figure out what the area is, look at, I have a base and I have a height that are going to be the same because they're isosceles. But that's only the green pieces. How many of those would you need to figure out what the area is? This is what I see. 20 squared plus another 20 squared. What does that mean? 400 plus 400. What does that make? 800. Same answer, just done in a different way. You are welcome to do either method when you figure out what the area is. We're going to stop your notes right there.